mathematically and how we use those to make choices. So like one way that we randomly select things is a simple shuffle up, like rearrangement. But if we want to do that mathematically, I reassign things. So who knows how the Phoenix Lottery works?
I do not.
Like when we pick students, did we actually pick Leah Lindemeyer? Like, we don't.
Do you pick her house number?
No.
You pick your email address.
No.
You start actually recording.
Yes, now I
Yeah,
know.
because Leon's not here.
So we recode everybody as a number, and then we randomly generate numbers, and then we take the numbers and go back and match them back up to the students. So that in the process of choosing, what we're doing is just choosing numbers. Well, the way that we can choose numbers is we actually have a random number generator in our calculator, which I'll show you guys that in a minute, and it will just randomly generate lists of numbers. And when you have a computer randomly generate, there's no bias. There's absolutely, it will make every number appear the same amount of times once you get to the end of the list. So you know distribution was even and it was completely random. Yeah.
What's the probability of distributing pi?
Of what?
Distributing pi. What's the probability of getting random?
What do you mean?
Like, what's the probability of distributing random?
You mean like the frequency of numbers happening?
No, like, what is it to get to pi? Like to count out pi. What's like the probability?
Probability
to
of
generate
what?
random numbers that.
Oh, you can look at any. So that is one way to look at random numbers is the digits of pi in the decimals are random. Like when you look at any given sequence. So every combination of numbers ever will be in pi somewhere.
No, like what is the probability that you can distribute random numbers that are
I don't think
order
you're
you
asking.
get
in the
would
order,
be
like in the order you get
3.14159.
What?
in pi.
I don't understand what you're asking. Are you asking what's the
So-
probability that when I look at a list of numbers from within pi, they are random?
No.
Okay.
What's probably a list of
I think it just needs
Explain this, I
rephrased.
got
My
it.
brain's not.
Okay.
Can you?
So if you shuffle a bunch of random numbers, right?
Yeah.
What is the probability that the order of those numbers will end up being the order of pi?
In pi anywhere, 100%. At a specific location, very, very low. Like very, very low.
So if you have like a list of random numbers.
Yeah, what's the probability that it will come up and give you pi?
Yes.
Extremely small.
Isn't it?
Because every digit that we move, like forward, or every digit that we generate, would give me 1/10 of a chance that it is the number that I want. So if I started generating numbers, and the first number, if we want to generate pi, that'd be a 1/10 chance to get 3. I have a 1/10 chance to get a 1. I have a 1/10 chance to get a 4. So as I keep going, it keeps getting smaller and smaller and smaller, or really my denominator multiplies by 10. So it'd be 1 over 10 to the power of however many digits you have. So if you want to talk about what's the probability that I line up 7 digits, and they are the first 7 digits of pi, it would be 1 over 10 to the 7th. Because I have a 1/10 chance in every location to get what I want.
So wouldn't it
Like,
be
isn't
10 million over infinity?
It'd be 1 over 10 million.
10 million.
Because 10 to the 6th is
No,
a
I'm
million.
saying get like. all
Or
of
no,
the
10 to the
pi.
5. No, 10 to the 6 is a million. So this would be 1 over 10 million.
Well, yeah, but I'm saying to get all of pi, like every single digit.
There is no all of pi.
Yeah, exactly. So it'd be 1 over infinity.
Yeah, which we can't do that. So it'd be undefined. Like, or impossible, we'd say really.
You cannot
As
do it
close
in
to
separate.
impossible as it can be. Essentially, it's impossible. Like, that's the difference between theoretical math and like real math. In theory, we could figure it out, but since there is no end, can't ever actually get there. All right, so back to a simpler problem. A class of 25 students wants to choose 4 students at random to bring food for a class party. Any set of 4 students should have an equal chance of being chosen, right? Because everybody has an equal chance of being selected, so any set of 4 has an equal chance. So what are some ways that the class could determine a random selection of students? How do we talk about random choices? Easiest one,
Probability.
shuffle up, draw names, right? How else? If you were asked to make random lists, say you're selecting something for the 8th grade. Robert?
A generator, like on a computer.
A generator, can we generate names?
Yeah.
Can't generate names.
No, you can associate
You can assign
the
numbers
names
to
with a
names
number
and
and
generate
then
Ah. So we'd assign numbers to everybody and then generate numbers.
Have everybody stand in a circle. You're in the center of the circle. You close your eyes and spin in circles, and then just
Yeah, so how would you call that? What would you call that method?
randomly spin in circles with your eyes closed.
Like random, would that be
Random circle
geographical? Or would that be, yeah, it has to deal with geometry a little bit, but not real, like, it's just like random pointing. There'd still really be a bias in that though, in a way. Because,
chance. If everybody's in a circle.
You would have
okay,
to have people in a
and if
circle.
you literally, yeah, and you literally have no clue and you're like blindfolded, then sure, I guess
You're
we can.
blindfolded before they even.
Okay,
get
then we can remove the bias. But the argument would be not everybody would necessarily take up the same amount of space in the circle. You'd have to have like, say like a clock-like setup where everybody has a certain region. You know what I mean? You'd have to take a whole circle, 360 degrees, divide it by 25, give everyone that many degrees of the circle if I'm just going to stand and point. You know what I mean? Everyone has to have an even chance.
All right.
So
fine.
that's what we would have to make perfect.
So what would we call that?
I don't know. Because I really like, I don't know what we would call that.
Geographical
a
clock
pointing
pointing.
circle.
Yeah. So there's lots of different ways we can do this, right? Easiest way is use a computer.
Don't give me that look. You just said.
Other ways, I think we covered most of them. Yeah, okay. They don't go through all of them here. We get more in depth as we go.
Can you figure out what was wrong to someone's book?
There's like, I think there's like a line of pixels that's goofed up, but I just had to reset the computer a few times. It was the updates that I ran. So this is how we calculate, so expected value. So if I were to choose one of you randomly from the stack of cards, what is each of your probability of being chosen? You have one out of however many people are here, right? So if A is an event that includes outcomes, A1, A2, A3, all these possible outcomes, and value A sub n is a quantitative value associated with each outcome. The expected value of A is all those individual probabilities added together, right? Because if I take, let's say, how many people are there today? 15, I think. So I take your 1/15th and your 1/15th and your 1/15th and your 1/15th. When I sum all those together, that's all my options. So if everybody has an even distribution, I should be able to sum all my values of their probability and get 1, because it's just a whole event. 100% chance happening. So on each of these, I showed you the process for the problem, and then the got it we're going to do on our own. So we have 28 students in a homeroom. We want to choose 4 for a committee. So we could put the names into a hat. That's kind of an old school method. How could a random number table be used to fairly choose the students?
Could you assign the kids' names to a number and then randomly shuffle the numbers inside the table?
Ooh, yeah, kind of, but we don't actually have to do that then.
Oh.
See if I can remember how to get here.
See how it is.
Which option is it?
Mr. Hudson,
Yeah,
do you know how to get like the concave notepad that the guy uses?
I do not.
Is there a way to play Pac-Man on these things?
Guys, that's the sort of stuff that makes me feel like I'm dealing with children.
The tapping or Pac-Man?
Oh, I'm assuming.
Man, I forget where it is.
Oh, mine?
Yeah, I forget exactly where I have to go. I'll find it here in a second. So what we would do is use a random generator to generate any sequence of numbers. You could have it generate 1-digit numbers, 2-digit, 3-digit, 4-digit. So here we generate 5-digit numbers. We then use that list of 5-digit numbers that it generated to group into into 2-digit numbers, but realize that anytime we have a 0, that just means it's either going to be a 0 at the end of the number or a 0 before, which really gives you a 1-digit number using the 0 in the first digit. So look at the groupings that we did. This is where people normally get mixed up, so this is why we're going to take a second. 18 is a 2-digit number, so that drops down. 82 drops down. 3 and then the next one drops down. 81 drops down. 60 drops down. So I keep doing that. But if there's only 28 students, I would have only had numbers 1 through 28, right? So 82, that doesn't make any sense. 31 doesn't make any sense. So I look at the first 4 numbers that I see that could be the numbers that I want, numbers less than 28. So 18 is the number, 9, 26, and 17. Those are the first 4 numbers that could be my students. So those are the first 4 that I use.
Is that how Phoenix works?
That's how they do it over at the, but you guys are assigned, there's different, like, if you think about hats, there's different hats that they pull out of, because there's each side of the river, and then boy, girl. Since we do even distribution boy, girl, and each side of the river. So we'll do, like, a Thomas boy, Thomas girl, Kilborn boy, Kilborn girl, and start back over.
How many do you pick?
We 80, but then there's always extras based off siblings and things like that.
Is that why we have like 172 kids?
Yeah. So, same type of situation. Teacher wishes to choose 3 students from a class of 25 to raise the school's flag. What number should the students or should the teacher choose based on this line of random numbers? So give this a shot. Drop down what your double digits are, or you can kind of group them. Last year I had people that just wanted to circle or box around each pair so that I can use those 2-digit numbers. I'm going to try to find there.
That's what. Are these random numbers?
Yeah, those are randomly generated.
So is this question basically asking how would you do it?
Yeah, what numbers would you choose? What numbers get chosen in this situation? If you use that random list, what numbers get chosen? So we start just like we did in the example. We had the 18 or like 18823. Well, the 18 is my first 2-digit number, so I drop that down. That's one of my numbers. 82, I drop that down. I don't need, like, I'm not going to use it, but it's still one of my numbers. So here, when I start listing numbers, my first one is 65. My next one is 35. My next one is 87. And now I've bumped onto my second set of numbers. My next one is 04.
So
And we keep going. I've only made it through my first 2, or first 3 sets of numbers there.
Well, you only need 3 stuff.
I only need 3 people within the first 25 students, right? So Greg, what'd you find?
Well, I took all of them, but the first 3 are just 0, 4, 14, 0, 9.
there was a 3 in there.
Where's there a 3? What?
After 81.
What?
Oh, it's
No. Oh, you kept going. So I agree. This keeps going. After the 09, I get to 87, 14, 98, 95, 0. I only made it to here, but I found my first 3, so I don't need to keep going. I could keep going, but I already found the first three students. So it'll be the 4th student in the list, the 14th student in the list, and the 9th student in the list.
Oh, okay.
Is this gonna be
And this is like, so when you go online, and you may not always have a TI-83, but if you just search random number generator,
My calculator has
random.org is pretty good. So you can do a min and a max, and it just generates off there. So I could honestly do a min and a max of 25 if there's 25 students. So then my first one could be 21. My next one could be 6. My next one could be 1. So then this generates 1 at a time instead of generating a list. Hmm?
That'd be fun.
And then there's other, like, you can check out other things.
Random drawing.
Yeah, like, how do you draw randomness? I don't know why this won't let me capture while I'm like using my mouse. Questions on what we did here? We just break all the numbers it gives me up into 2-digit numbers. Cool. Just updates and things like that. Alright, so we move on to problem 2 here. Again, the first one is solved out for you. Oh my gosh. Alright. So a cereal company is having a promotion in which one of 6 different prizes is given away with each box. What's up?
I have to ask you a quick question.
Okay.
So go ahead, keep going.
So if the prizes are all equally distributed, this is kind of like Cracker Jack or anything else like that, and randomly distributed, on average, how many boxes of cereal will a customer need to buy in order to get all 6 prizes? Well, that's kind of confusing, right? Because I might buy 6 boxes and get all 6 prizes. I might buy 6 boxes and get all the same prize.
Or you might buy 6.
Or what?
Might buy 6 and get none.
Well, there's prizes in every box, right? They say. So they're just randomly they say. They're just randomly distributed through the boxes.
They're cheap prizes then. Worthless.
This logged me out.
They're like tattoos.
So check it out on your paper. This logged me out for a second. So let me see if the PDF's good enough.
Oh, I know what you. Oh, I see.
I will say that when I was little, the prices in cereal boxes were way better than today. They were actually
Yeah,
like,
they were rad.
they were cool. Like,
Because I was
They were things you
look
could-
for the
That's where it
prizes.
is.
I always liked the characters right there. Throw it in the little parachute.
So let's check this out. I want to see if live right now we get the same result as what they got. So this is where on our TI-83 we go, and I just found it, but I forgot how you have to enter it. The button you want to find in your calculator is random integers. Here's how you get to it. You go, where did I find it? List. Just found it.
15.4 boxes of cereal get
You only buy like 2/5 of a box.
What are you looking for?
Random integers, and I had just found it on my. It's in the drawer.
If you, I think I got it.
What'd you hit to get there? I forget which
I
menu
went
it's
to
in.
apps and then probability and,
Found
it. You go to math and then probability.
So, and then random numbers.
Yeah, so there we go. Math button,
Yeah, that's how it
probability, random integers.
Wait, did you?
Oh, no.
Okay.
I did. Yeah,
There's different routes to get into it.
If you go to apps,
Apps.
Yes.
Here we go.
Well, your apps might be different than mine.
Go.
All right, math, probability, random integers. So let's try this. We want to generate random integers starting with 1, going up to 6. So 1, 6. If you don't have that comma there, it goofs it all up. That's why a second ago I could not figure it out. So first one it generates is 6. 6 again, 1, 4, 3. So we need to write these down so we can figure out how long it takes us to get the boxes. Grant and Ben, you want to help me out here?
Okay.
Grant, keep track of how many boxes we have chosen. Ben, keep track of if we have gotten that prize.
Okay.
So right now we've chosen 5 boxes. We have prize 1, 3, 4, and 6 so far.
5.
How do you put the comma?
The comma
Yeah,
button
it's
right above the 7.
7.
So if I generate another, ooh, now I got prize 5. Generate another, well, I got prize 1 again.
Oh, so it's generating for you.
Yep, just randomly. Generate another, got prize 3 again. Generate another, got prize 6.
You might want to write down.
Oh,
There you
there's
go.
prize 2. Do I have all of them yet?
Yep.
How many did it take me?
10.
10. So based off this, all of ours were collected after the 16th box.
That's pretty low. That only has two tens. That's good.
Yeah,
That's-
so then we can
there
run
was
it
one
more and
that was
more and more times. We can continue to simulate this. So we did 20 simulations, essentially. So the first simulation we just did together, where you guys said it took us 10, they average it out. After all 20 simulations, it took them 308 trials in all 20 simulations. So they take their 308 over 20, and they get about 15.4. We would assume that if we did that 19 more times, we'd get approximately the same answer that they did.
There's our house. 23.
Yeah.
We'd have to buy 23 boxes before we get it.
So try this in the Got It.
That's fun.
Try it. If you don't have a TI-83, work with somebody close to you to generate the numbers.
Hey,
That's cool.
hey, 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 fine.
I
No.
got you.
We talked about this last week, yeah. He hasn't. Nope.
You
Not,
have it,
nope.
right? Did you just have it?
Yes. Yeah.
He's asking me to unreport it.
It's the same thing. You're just, yeah, it's the same thing to generate. So actually, yeah, pair up. This is a lot easier when you pair up.
No, go get a TI-83 now.
No, Greg's
Wait, Mr. Hudson.
Yeah.
I'm confused on how they got it would take 15.4 boxes. What did they do?
So we did one trial and it took us 10. So that would be 10 over 1. We then restart and we like wipe out our 1 through 6, and I'm looking again for 1 through 6. So what we really actually have to keep track of, if you were confused at what we just did,
Oh, it's
watch
just
up here.
It's simulation trials.
Yeah, so I've done 6 trials and I've gotten 1, 2, 3, 5, and 6. So I'm missing 4. So a 7th, a 7th, an 8th, a 9th. So it took me 9 trials to get all 4 of them. Or not, so that'd be 9 out of 1.
So you did that many trials.
Yeah. So it took me 9 options to get all of them
And then you
once.
divide by.
So then if I do it again, I like start over. I say, all right, there's a 6.
How many simulations do we do? How many simulations do we do?
Like really as many as we can. We want to compare data across the board.
Seth's trying to get 666.
I got 2.
So my trial, it only took me 9 times actually. So wait, I just heard you say, Emily, how many times did it take you to get all 6? 22. It took Emily to get all 6 of them. Who else has how many trials it took them? 11.
14.
I heard 14. I heard a 12. 10. So then, at any given point, we can stop and say, okay, what's the average of trials it will take me? Well, if I have 5 data points here, I'm going to add all these up and divide by 5 to find out what the average amount of trials was, or the average amount of rolls that it took.
Oh, yeah, actually, I like that too. Oh, just 5 and 6. That's still 1/8 chance. Yeah, it's really high.
Yeah, sometimes you're just waiting for one more number and it just keeps not coming up.
No, I thought I might have got like
Kill, you still haven't won yet.
That's where it is. That's what I put on. Yeah, that's what I
I
did.
don't think we can be friends anymore.
See?
So here's their series, and you can use random any number of digits. So they did random 5-digit numbers. So if we wanted to generate 5-digit numbers, I could go back to random.org and say, okay, my minimum is 9,999, which actually it will include the minimum. So I'm going to make my minimum 10,000. And my max will be 99,999. So my first one, 5, 2, 2, 3, 4. So really, I rolled a 5, a 2, a 2, a 3, and a 4. If we're just using these as random numbers. Now I rolled an 8, a 6, a 6, a 4, and a 3. Now I rolled a 4, a 9, a 5, a 2, and so that's how they're getting their random 5-digit numbers. They just list them all out, looking at them as 1-digit numbers, and figure out how far it took you to actually get all 6. And there is not one right answer here. This is just, in this trial, how many times did it take? And then we can do it as many times as we want to get a good average. Questions on this?
Nope.
This makes sense. We just randomly generate numbers and look for what we're looking for.
Yeah. I'm trapped.
So suppose we're at a carnival throwing darts at a dartboard like this one. Not a very creative dartboard. There's equally likely chance that your dart lands anywhere on the board. You receive 20 points if your dart lands in the white area, 10 points if it lands in the red area, which kind of looks like orange to me, and negative 5 points if it lands in the blue area.
What if you hit the guy?
How's that?
Yeah, no.
Then you get plus
How many points can you expect to get given that the area for the regions respectively are 36 inches squared, 108 inches squared, 432 inches squared, and the total area is 576. Now this is done on your paper, but without looking at that, who thinks they can process through like why we're gonna do what we do? Like when I think about what's my probability of gaining 20 points? What's my probability of gaining 20 points in the white area? Well, the white area is 36 inches squared. The total area is 576 inches squared. So taking skill out of it, because obviously if you're really skilled, that will change the probability. But let's say you have equal probability. You're just equally good at this. So we then, to figure out the probability of getting white, we'll take the area of the white over the area of the total. But since we want to look at total points together, check out what we actually do here. I think I moved this for the time. Yeah, the text moved. So we take that probability times my 20 points. We then take the probability of the red region and multiply that by the points of the red region. And we take the probability of the blue region, which is really, really big, and multiply by the points for the blue region. Notice, if everything is random, am I going to gain points or lose points? Lose points. As the game goes forward, if these probabilities come out to be true, I'm going to lose points. Now that's where skill will change the probability. But if I am not skilled at this, if I have random chances, I will likely lose 0.6 of a point every time I throw a dart. Now I obviously can't actually lose 0.6 of a point, but when I average all my points together, that would be what we would expect to happen.
They also didn't take into probability that you might miss them.
Yeah, that you might miss completely. So we'll say only darts that hit the board count. So any darts that don't hit the board just get thrown away. So try this in the got it, but now our point values are different and the size might be the same. Yeah, the size of the board is the same. So try this in the got it. What are you likely to do on average with every dart? What are you likely to do on average with each dart? confused? Are we okay? You should have set up something very similar to this. Anyone have their final sum?
Yeah.
Any random dart would carry a value of. Did you say negative 3.86? 2.86? Approximately negative 2.86. So every dart is likely to lose over 2.5 points. Did you get something different? I haven't checked this yet, but.
I just got negative 2.2.
Negative 2.125.
Yeah,
I was wondering where he got that.
Yeah, I get a 125. Check that. If you rounded anywhere, that might have been where the issue came from.
Not round. Round
Where that
means back.
6 at?
Especially for short.
Questions on this?
I have a
Take the probability of the region times the points of the region. Go ahead. I heard you.
Okay, so Wolverine, how do you think he like goes through those metal detector things at the airport?
Wait.
What do you think? Who does?
You're really choosing the wrong details to care about how do you think. How do you think blades retract up into someone's body?
Okay.
If you're going to argue the legitimate. Yeah, like my dad's pacemaker. All right, last thing. This is when coaches can use math to determine what should we do in a given situation. If it's raining, what's our probability of getting a field goal? If it's not raining, what's our probability of getting a field goal? Against this team, what's our probability of actually getting a touchdown? If we rush, what's the probability of getting the rush through? So, on an opening drive, a football coach must decide whether to kick a field goal or go for a touchdown. Now, he knows that a field goal is worth 3 points and a touchdown. We assume the point after is worth 7. Because if you miss the point after, well, that's, So, field goals, pretty easy. We know that all that really matters is the kicker. There's a very low likelihood that somebody will actually block the kick. So we're going to say we have a 90% chance of getting the field goal. Touchdowns, much harder to run that ball in or throw it in. We got a 35% chance, about 1 out of 3, a little over 1 out of 3. So we do the same thing here that we did for the points on the dartboard. And we just set up what's the probability of getting a field goal times those points. What's the probability of getting a touchdown and the points that we would get from that? Well, based off this probability distribution, which would be better? Which has a better outcome? Field goal, right? So, because I'm more likely to get a field goal, that's a better outcome based off the points. But if my field goal percentage, let's say my number one kicker is injured. Let's say instead of having a 90% chance of getting a field goal, this kicker, not as good, has a 6. You're going to do 70? 70 will make it real close. Let's do a 70% chance. So if it's 70% chance times that 3 points, what would that come out to be? 2.1. And if it comes out to be that, which one's easier? Or which one's better? To run it in for the touchdown. So if my number one kicker is injured, maybe I then decide to run it in for a touchdown. And of course, other things go into play. How far in the game is it? Blah, blah, blah. But this was opening drive. So the other team doesn't really relate. Ben?
What if you're starting running back is injured?
Yeah, and then it changes the field goal percentage. Yeah, or changes the touchdown percentages.
All of a sudden you have a 2% chance of scoring a touchdown.
A 2% chance? Yeah, I think I would go with the field goal then.
Ben's the running back now.
Crap. Of course, I hit capture, and it decides to capture it after.
Third grade. I said you're wrong.
Yeah.
The whole point of Madden is to go for it on like 4th and 50.
Yeah, I know. But that's not mathematically sound. That is a risky choice because the probability. Like, that's why And in Madden, does that like gain you points or something? Like not points in the game, but like. Okay. I didn't know if it gained like credibility points or something.
Sometimes I purposely get down to like 30.
All right. So Ben, like you were talking about, our whole A-team line.
Oh my god.
Our starters, our upperclassmen, they're all injured. Or maybe they all came down with the flu or mono because they shared their water bottles. Don't share water bottles. So, my percentage of probability for getting a touchdown here is 30%. But my kickers are sick too. I only have an 80% chance of a field goal. So if I did an 80% chance of the field goal, what would that expected value come out to be? 80% of 3 points. 0.8 times 3. 2.4. My 30% of my touchdown comes out to be 2.1. Which would you rather go for here? The field goal. If you made your decision based off the math, you'd go for the field goal. However, you don't always make your decision based off the math. You sometimes make risky choices. That's okay. That goes down to the coach too. Does this make sense? What we've done today. The random modeling, randomly generating numbers. Wunderbar. So tomorrow you want to come, homework's done and organized, ready to check them. You got a couple minutes to go ahead and get started on this.